Finishing up chapter 6 now. Remember, we're skipping section 6.6 and focusing on 6.7 to wrap up chapter 6. Here's page 1 of the notes. So we're going to talk about negative exponents in scientific notation. And our first set of problems in this set, the instructions say write each expression with positive exponents only and simplify if possible. One of the things that you'll start to hear a lot about is the fact that an answer isn't finished until all the exponents are positive. We can't just go around changing negatives into positives. So we need to have a mathematical reason, a pattern that we can stand on. Let's go back to this little pattern that we looked at in the previous section. So I've retyped it here for you so you don't have to copy it. We had looked at that as you go from 10 to the third, to 10 to the second, 10 to the first, and finally 10 to the 0, what you're doing each time is dividing by 10, or removing one of the 10s each time, or subtracting 1 from the exponent. Okay, so that was what was happening each time as you went down the row here. At the same time, the results of 10 cubed being 1,000, 10 squared equals 100, 10 to the first is just plain 10, and then the result of that pattern is that 10 to the 0 equals 1. And what was happening here is also we were dividing by 10 each time, or thinking of it as move the decimal to the left one unit or one place. Okay, so in that final move, if the decimal's at 1,000 out here, it moves 1 and you're at 100. And then it moves again and you're at 10. It moves one more time, you're at 1. So the question now comes is, what happens? Can we continue this pattern even further? And you can. You can go one more here. We can still divide by 10. We can still subtract 1 from the exponent. If you subtract 1 from 0, you're at 10 to the negative 1. What does it mean to raise something to the negative exponent? Here, if we're just taking away a 10 each time, and we landed here at 1, well, what do you take away to get down? So now we need to look at this pattern more closely here. 1,000, move the decimal, move the decimal, move the decimal, or in a sense divide by 10 each time. In terms of moving the decimal, if you move it one more time, you're actually in front of the 1, you're at 0.1. In terms of dividing by 10, you would think of that, you would take 1 and divide it by 10, or you'd get 1/10. Notice there, the exact same thing. 0.1 is the same as 1/10. That's what it is. So our answer here is 0.10 or 1/10. Now, one example doesn't make a rule, but you could do this with any number you want. You could put 4s here instead of 10s, or 5s, or 19s. However you did that. Now the numbers would get kind of crazy here. It wouldn't feel like you're taking away a 0, and you wouldn't be dividing by moving the decimal, but you would still be dividing by that number over and over. And on that last one, where you had something to the 0 equals 1, again, to go one more step, you'd be dividing by that base, and you put it to the negative 1, and you take that 1 and you divide by whatever the base is. If these were 4s, it would be 1/4. 10 to the, or 4 to the negative 1 would be 1/4. So the rule here is, and I like to say, when you see a negative exponent, don't flip out. In other words, don't panic. So don't flip out when you see a negative exponent. Instead, you're going to flip the base. In other words, the number itself, treat it as a fraction and flip it around, make it the inverse. So let's look at what that means. Let's look at page 402, number 4. If I have 4 raised to the negative third, that negative right there, if I had 4 to the negative 1, that would take this 4, which is really 4/1, it would flip it to become 1/4. The negative would do its job and flip it. Okay, so let's look at this. The 4 to the negative third means that the negative would flip the 4. The 4 is really 4 over 1. Flip that, it becomes 1 over 4. So the negative itself has done its job. It's done the flip. And the cube is still here. It's still up here, the whole thing cubed. Or you could say it's 1 over 4 cubed. It really doesn't matter. Those are equivalent because 1 cubed is just 1. But this whole thing, the fraction flips, the negative does its job, and that cubed is still left here. In this case, it would become 1 over 64 because that's 4 cubed. Let's look at that again. What's different about this one? Well, it's still 4 to the negative 3, but now it's in the denominator. So what does that do? Well, again, it doesn't flip out. It just flips the base. So instead of, so this negative now moves it to the top. So this becomes 4 cubed up top. Another way to think of that is it flips this completely, and it's like 4 over 1 cubed, or just plain old 64 again. So a negative, don't flip out, the negative exponent flips the base to the other side of the fraction, and then it takes that exponent with it, only now the exponent is not negative, it's positive.